Good day, viewers all over the world. I remain Salumaj. Today, I'll be talking about inorganic chemistry. Another inorganic chemistry I want to talk about atomic structure, electronic configuration, and orbitals. Orbitals. In our last class, I spoke extensively about elements, compounds, and mixture. So today we want to talk about atomic structure. So what's an atom? Say an atom is an indivisible particle that takes place that is found or that takes place in a chemical reaction. Don't forget the topic, the definition I give us under elements. That an element is a substance that cannot be broken down into substances. Meaning that when you're talking about elements, you are talking about what? Atom of an element. So in an atom, we have divisions and some parts that normally take part in your chemical reaction. So there was a scientist that did work extensively, an English scientist. His name is Dalton. So they call it Dalton atomic theory. He came up with different laws that, though the law later became an hypothesis because it was contested, that energy is neither created nor destroyed. But some scientists now came out that no, that at times energy can be lost in a chemical reaction. That, for instance, if you put sodium hydroxide, well, put water in sodium hydroxide, what you experience that heat is generated from that reaction. Your sodium hydroxide is your caustic soda you buy in the market. So if you see caustic soda, that's the sodium hydroxide. If you pour water in it, it's solid. By the time you pour water in it, it will dissolve. And after a while, by the time it touch the body of your beaker or your plastic, it feels warmed. That means that energy has been released into the environment. So that's by the time you get to your 100 level, that's when they will now be talking about the isothermal process, adiabatic process, isochoric process. That's where they got all this. That's first law of thermodynamic division from it. Second law of thermodynamics. So that's under physics. So here, our concern is how atom is divided. By the time God help you, you enter university, you understand more. And please, if you can follow my video, I will still enter into that isothermal, isochoric, adiabatic process, and you just have the full gist of everything. So he also said that energy can neither be created nor destroyed. But from that research, we discovered that energy can be lost into the environment. And there are times that by the time you react some chemicals together, by the time you touch the body of that container, it feels so cold. That is what an endothermic reaction. I will teach us that one by the time we get to enthalpy change, chaos, the spontaneous reaction. So for this one now, our focus is on atom. I say atom can be divided into two. Your atom can be divided into two. We have your nucleus and you have your what? Your electron. Your electron can further be divided into two to give you your proton and your neutron. So I can say that atom is divided into two, depending on the information you want to supply thereafter. That's nucleus and electron. Or I can say that an atom is divided into three. Maybe I just want to jump nucleus and say it's proton, neutron, and electron. Either you say two or you say three. Your next statement will determine whether you are right or whether you are wrong. And then proton is positive, while your neutron is what? Neutral. And your electron is negative. And your electron is the only directly opposite to your what? To your to your proton. This is your shell. This is your shell. This is the nucleus. So in the nucleus, you have the neutron you have the what? The proton. So surrounding this nucleus now is a shell. We call it the K shell. Is housing the what? The electron. The electron is moving around this K shell. This is K shell. And this is your what? Your electron. Is revolving around the nucleus. This is your nucleus. I can rub off this neutron and proton and put nucleus. It's still the same thing. So we have the K shell that houses the external electron. So an electron is moving around the nucleus. So, and that is does not stop there. We can have K shell. There are seven shells anyway. We have the K shell. This is the nucleus. We have the K shell. We have the L shell. We have the M shell. We have the O shell. Just like that. And it dependent on the number, or let's say depending on the atomic number of that atom or the element. For instance, now, like I told us in our last class, I said we have over 103 elements scattered abroad, scattered everywhere. But scientists came together and grouped these elements based on their atomic weight. Based on their weight, I will still talking about mass number very shortly. So hydrogen is very light compared to helium, compared to lithium, compared to beryllium, compared to boron, compared to carbon. For instance, yeah, like I said, we can have helium, which is He. Helium, He. So they used what they call it, the Latin name, to coin out the letters for all these elements. Look at somewhere you can see copper, you can see Cu. This is copper. This is cuprum. Sorry, this is carbon rather. This is carbon. C is carbon. This is cuprum, which is what? Copper. You can have Au, which is aurum, and that is your gold. So they use the Latin name. So if you see one letter, or when you see two letters, they are just using that one to denote or to connote all those elements. So don't be perturbed, don't be disturbed. So we have helium. So they arrange them based on what we can easily understand. No, we play with numbers, we play with letters. So that's what they use to pass the message across to learners so that they can easily understand what they were trying to teach. So they said hydrogen is one, in terms of weight. Let's say let it now come literally. Maybe you have a scale. By the time they weigh hydrogen, one hydrogen we give them one. You now say helium, you give them two. Have one point something, but let's approximate to be one. Helium, two, let it be two. You can have lithium, which is Li, let it be what? Three. You can have beryllium, let it be four, five, six, seven, eight, like that. You can have carbon, you can have boron. Okay, let me continue. You can have boron, that one is five. You can have carbon, that is six. Just like those. So, okay, let's continue again. You have nitrogen, we have nitrogen, which is seven. We have oxygen, which is eight. So, just like that, let's stop there. So, all these things is what I want to use to explain the atomic number, the electronic configuration, then orbital arrangement of electrons. So, we have this now. We want to put this one into electronic configuration. Don't forget, I told us that we have number of shells surrounding a nucleus. And when I'm talking about nucleus, let your mind be talking about what? Proton and neutron. Please let your mind be casting on what? Proton and neutron. That is the core, the inside. So now we have K shell, we have the L, we have M, we have O, as go forth. And there is a formula being given to determine the number of electron or the number of shell to every element. And that formula is what? 2n squared. Meaning that how many electron will I can occupy the first shell, where n is the number of shell. So if I say n is equal to 1, let's say shell 1, how many electrons will be there? That will be 2 into bracket 1 squared, and that is what? 2 times 1, which is equal to 2. It means that in the first shell, the maximum number of electrons you can have there is equal to 2. Let's say n is equal to 2. When n is equal to 2, that's 2n squared, which is 2 into bracket 2 squared. And that is what? 2 times 2 squared is 4, which is equal to what? 8. So it means that in the next shell, which is the L shell, the maximum number of electrons you can have there is what? 8. Then followed by the L shell, M shell. If you work it out, only that these two obey this, then the subsequent one disobey this, but it has to be written in form of 2, 8, 8, and so on and so forth. But let me just continue to see what I'm trying to say. So let's now take one for instance. Let's say we have, let me just pick boron. Boron is 5. That is the atomic number of boron is what? 5. When you hear atomic number, it's talking about the number of proton or the number of electrons. So boron is 5. So it means that I have 5 electrons on the external shell. This is what they call the external shell. The external shell, the KLM, they are regarded as what? The external shell. So we now have the nucleus. Don't forget, when you get nucleus, I'm talking about what? I'm talking about the neutron and the proton. So we have in the first shell, what's the maximum number of electrons you're going to have there? Is what? From that formula it gave us 2n squared. So the first shell will take 2 electrons. So if the first shell is taking 2 electrons, how many will be left here? Just minus 2. So I'll be left with what? 3 electrons. So it means that these 3 electrons will go to the next shell. And this is the next shell, which is the L shell. So this shell can still take 3 electrons conveniently because the K shell can only take maximum of 2. The L shell can still take up to 8, while the M shell can take more than that. But you have to break it down into 2, 8, 8. Although that's what brought about the orbital arrangement of electrons, but I will still teach that one in a very short while. So we have boron. This is now the electronic configuration of boron. The electronic configuration of boron is now 2, 3, meaning that first 2 electrons will be in the K shell. Then the remaining 3 electrons will be in the what? The L shell. I want to believe that is very clear. If I want to do for oxygen, the same way. What is oxygen? Oxygen is 8. Oxygen is 8. That is the atomic number, which is the number of electrons or the number of protons. So for me to break this one down, what is the maximum number of electrons in the first shell? Is 2. Then the next one can go to what? The next shell. So it means that I'm going to have, I said the first shell, K, L, M. The first shell is this. That one can take maximum of 2. This one can take maximum of 8. But this is not up to 8. You put 6 to be there. So I have K, L, M. So this is 2, 6. So for me to now work further on this, I can now say that I want to put this one into my shell. So we have the first 2 shells. This is 1. This is your nucleus. This is your electron here. Then the second one we go here. 1, 2, 3, 4, 5, 6. So this is the electronic configuration of oxygen. The next one I would like to talk about is sodium. Sodium has 11. Sodium Na is sodium. It has 11. So break it down into electronic configuration. So the first shell, don't forget your nucleus. The first shell will take how many? 2, which is your K. That is 2. Then the second shell can take up to what? 8. 8. So 2 plus 8, that's 10. You still have 1 left. So the last one will go to the last shell like this. So you have 2, 8, 1. So that's the electronic configuration of sodium. So let's now go to the next one, which is your atomic number. We'll talk about atomic number and your mass number. So your mass number your mass number now. So, because we always talk about mass number, what's the mass number of this? What's the atomic number of this? Your atomic number is number of proton that I've told us. And where do you find your proton? Is in the nucleus, and I've drawn it for us. For your mass number is the number of proton plus mass number is equal to the number of proton plus the number of neutron, and it is designated as Z. It's designated as what? Z. Why your atomic number is the number of proton, and it's designated as what? A. We check out your textbook, see it there. So they now said the element, the element itself is designated as what? Is designated as X. So for me to now represent this, you can now have this, your X. This is now your mass number, and this will be now your atomic number. I'm already going into periodic table gradually, so that by the time I'm talking about periodic table, I don't need to be talking about this again. So you know that your max number is what? Number of proton, which is P, plus the number of neutron, which is N. So your atomic number is number of proton or electron, because I told you proton and electron, they will always counter each other. If proton is 5, electron will also be 5. If proton is 20, electron will be 20, so that they can balance, so that the atom can be stable. The only time they achieve unstable state is when they are reacting. They want to lose some electron to achieve stability, or they want to gain electron to achieve stability. By the time I start talking about periodic table, I'll be talking about the ionization potential, the ionization energy of an atom, the energy required to knock off what they call electron from the surface of a neutral atom. So that's about that. That's why at times they can tell you, okay, for instance, let me just give you an example. And this X, let's not forget, this X I said stands for an element. That element could be hydrogen, could be proton, could be hydrogen, could be helium, could be boron. For instance, let's assume that the X is sodium, and I say, what is the number of neutron in this sodium? Maybe I've given you this one as 23 and this one as 11. I say, calculate the number of neutron in this compound. Even without me writing what S is, mere looking at this and this 11, you should know that this level stands for what? Your sodium on the periodic table. I can also write like this. Maybe I can just write 16 and 8. I can ask you which element, I can write 8 and 16. I can ask you that which element is this? 8 and 16. Just look at this. You look at the atomic number on your periodic table. Once you just look at your atomic number on the periodic table, you will know which element is it. Like this now, 8. 8 is what? Oxygen, from what I've listed the other time. So for me to calculate the number of neutron in this, you already know that mass number is equal to proton plus neutron. So what's my proton here? What's the mass number? 23. What's the proton? Proton is what? 11 plus neutron. So neutron collecting the light time is equal to what? 23 minus 11. So the number of neutron in this atom is what? 12. So that's what they always ask you to calculate, and it's very easy. So in our next class, I'll talk about orbital, because orbital is just the subdivision of the shells. You know that your K shell is now subdivided into orbits. That's where you talk about the spdf orbital, then how the electrons are being arranged, the structure, the shape, whether it is star shape, whether it is spherical in shape, whether it is dumbbell, whether it's double dumbbell. Those are the things they will ask in your exams, and the ability to, you don't even need to cram anything. You just know it. The way I'm saying it, you won't do it better than me. Thank you very much for watching. My next video will be on orbital, then SPDF. Thank you very much. I remain Salumaj. If you have not subscribed, you can do so now. I'm talking to you. You can do so now. Please share this video to others so that they can also be part of this progress. God bless you.